Okay, this is the 4.3 causation association and correlation coefficient with scatter plots video. And so make sure you have your notebook and a pencil. You also are going to need your TI-84 calculator if you have one. You can use the one on your Chromebook if you have a school-issued Chromebook, or you're free to use Desmos. And so I'm going to show you how to do the correlation coefficient on TI-84 and Desmos, and then you can choose or pick which one you like best. There's also videos on correlation coefficient and videos on for using Desmos and the TI calculator in the Unit 3 resources, I believe, or the Unit 2 resources. If you go to the course tools and go to that page of the course notes, you'll find those videos in there on regressions. Okay, so your SLO, your student learning objectives, we actually have 3 today. The first one is A4A, calculating using technology, that's a calculator or Desmos, the correlation coefficient. A4B is comparing and contrasting association and causation. And A4C is writing with and without technology, your calculator or Desmos, linear functions that provide a reasonable fit for correlation coefficient. So your SLO for today is going to be, I can calculate the correlation coefficient using a calculator, write linear functions that provides a reasonable fit, and compare and contrast association and causation in real world problems. Sounds all really scary, but it's really not. We're going to go through it. It's going to be super easy. Okay, so the first thing is a little bit of vocab. An association is going to be when two things are related to one another, okay? So anything you talk about two things just kind of going together, then you would say those are associations. So like a candy bar and like, let's say Twix and Snickers. Those two things are not exactly the same, but they are associated to each other. Okay, so a person's age and a person's weight has an association. Those both belong to that person. So I'm going to ask you if these things are associations or not, and you kind of write them in your notebook if you think they are or not. So the temperature outside and the ice cream cone sells. You think those are associated or not associated? They are associated. The hotter it gets, the more ice cream cones you're going to sell. On a 100-degree day, you're going to sell more ice cream cones than you are on a 20-degree day. The amount of water in the ocean and hamburgers. Those are obviously two things that are not associated to each other. The number of boys and girls in class. Those are associated because they are both students. Car accidents and drivers' ages. Any parent that pays insurance costs for teenagers knows that those two things are definitely associated. Okay, now let's talk about causation. Causation is when one of those items causes the other one to happen. So two things can be associated, but if one of them causes the other one to happen, then we call that also a causation. So for example, the hotter the temperature, the more ice cream is sold. Those are associations, and one does cause the other one to happen. One other way to kind of remember this is cause and effect. The more I study, the higher my grade is. Those are associated, and one causes the other one to happen. The more I practice, the better my three-point average is. Those are both associated, and one causes the other one to happen. Not every association is going to be a causation. Two things can be related to each other, but one doesn't necessarily cause the other one to happen. For example, car accidents and the number of Ford Mustangs on the road. Those two things are associated, but the number of Ford Mustangs doesn't necessarily cause the number of accidents to happen. The size of paycheck and the number of hours worked. This one is a causation because if you work more hours, you make a bigger paycheck. If you work less hours, then you make a smaller paycheck. So that is a causation. The amount of gas in a car and the number of miles driven. That is a causation, association with causation. The number of dogs in the world and the number of cats in the world. Those two things are associated, but one does not necessarily cause the other one to happen. Now, causation association is pretty easy. They're going to ask you questions if they're related or not, or if one causes the other one to happen or not. Now we're going to get into correlation coefficient. So the correlation coefficient, there are 3 types of correlations we're going to look at. The first one is a positive correlation. I know that you guys learned about correlations and scatter plots in junior high, but we're going to take it a step further. And so this is an example of a positive correlation. This is an example of a negative correlation. And this is an example of no correlation. So when we collect data in the real world, it doesn't make a nice tight fit line. Sometimes the data is a little bit skewed and all over the place, and you have outliers. And this is what we're looking at. So now we're going to talk about a line of best fit. It's going to be a line that is going to hit most of the points or go through the middle of most of the points. Okay. A graphing calculator, you can compute the linear regression. Remember, we talked about that earlier when we were doing stat edit and using Desmos. And those videos are available for you that you can go look in the course toolbox. It's either in chapter 2 or chapter 3, and you can look at those videos to refresh if you need to. Now, the correlation coefficient in the calculator in both Desmos and TI is going to be R. The R designates your correlation coefficient. And we'll talk about what that is in just a second. And so a negative correlation would be -1. A no correlation would be 0, and a positive correlation would be 1. And now we're going to talk about those numbers between 0 and 1. So if 0 means that we have no association whatsoever, 1 would be a straight line. Every single point is on that line. And then as we go through that, we could have 3 different types. We could have a weak association, we could have a moderate association, or a strong association. These are the boundaries that you need to memorize. So from 0 to 0.3 is a weak association. Between 0.3 and 0.7 is moderate, and 0.7 to 1 is strong. So that's one of those areas you're going to need to commit to memory so that you can be efficient whenever you're trying to discover these correlation coefficients. So let me show you examples of what these correlation coefficients look like. So if you have a scatter plot that looks like this is obviously no correlation at all, and so it would be R equals 0. We would not have a line of best fit. This would be a weak correlation. You see that the line goes through some of the points, but the majority of the points are really far away from the line. So we would call this a weak correlation. This would be an example of a moderate correlation. And you can see that we can draw a line through and hit some of the points, and the points are tighter and closer to that line. So this would be moderate. And then this would be an example of, that would be an example of a strong. And then this would be an example of a straight line, a linear correlation straight through. So anytime you have 1, that is going to be a straight line. So you can see as we're going through these, you can see the differences in how we could use this correlation coefficient. We can determine how good our data is by using the R value or the correlation coefficient to tell us. Now, I'm going to show you how to do this on the TI-84 calculator first. So I want you to watch through this, but if you decide to use Desmos, that will come next. So on the TI, make sure you hit second plus 712 and clear the calculator. And now we're going to use this example to help us. This is the calories of fat in selected fast food meals. So as you can see, what's happening to the calories as the fat grams get higher, the calories are getting higher. And so now we're going to show a scatter plot of what that looks like. So on your calculator, I want you to click Mode and then turn on Diagnostics. If you don't turn on Diagnostics on the TI-84 calculator, it will not tell you what the R value is. And so you'll be able to do everything right, but it still won't be there. So one of the things I want you to do is every time you pick up the calculator going forward, I want you to click Mode and turn on Diagnostics. Now, we're going to use the edit feature of Stat Edit. So this is just Stat Edit. You've done this since junior high. And so I want you to hit Stat Edit. I want you to enter the data for fat, L1, and the data for calories for L2 into your calculator. Remember, if I go too fast, you can pause your video to catch up and then rewind if you miss something. So now I want you to use the calc feature. So you did Stat Edit, you put in L1 and L2. Now I want you to hit Stat, the right arrow key, and we're going to pick Lin Reg for linear regression. And then we're just going to hit Enter all the way down. When you do that, it's going to bring up a screen that looks similar to what I have here. It's going to say the format is y equal mx plus b or y equal ax plus b. It's going to tell you that this is your slope. This is your y-intercept. And then you have this R value at the bottom. Now, before we turned on diagnostics, we were doing this in previous chapters, all you could see was the A and B. But now that we have diagnostics turned on, you can see these R values. We're not going to use the R2 value right now. That's for something else in statistics later down the road. But we are going to use the R value. That's your correlation coefficient. And our correlation coefficient on this one is 0.97. So think about where that falls in that chart. Is this going to be no correlation, a weak correlation, moderate, or strong correlation? Well, in this one, we would say that it's going to be a strong correlation. So the equation is going to still be y equal mx plus b. So it's going to be y equals 13.61x plus 150.87. And then the R value is 0.97. Now, you notice that I rounded to 2 decimal places. For everything we do with linear regression and correlation coefficient, you'll round to 2 decimal places. Now, once again, remember 0.97 is a strong correlation. That means most of the points are going to be on that line or very close to it. Okay, now we're going to do the exact same thing, but we're going to use Desmos. So if you want to open up Desmos, you can go to desmos.com/calculator, or you can click on the Desmos on my Canvas page. Or if you have a school-issued Chromebook, hit the circle at the bottom left-hand corner of your screen. That's your apps, and then go click on Desmos from there. Okay, so now what we're going to do is for step 1, we're going to use the same example. I want you to click the plus, and then whenever this little menu pops up, you're going to click table. Then I want you to enter all of these values into that table, and you do have to enter them all. Don't enter just 1 or 2. You have to enter all that you have. It will change the values that you'll get. After you enter those into the table, then on the second line, I want you to enter this. And it's really easy to remember. It's y equal mx plus b, but you have to say y1. And when you type y1, the 1 will automatically become a subscript underneath. And then you're going to type this little tilde. On most Chromebooks, most computers, on a QWERTY keyboard, you'll hit Shift, and up at the very top left, you'll see the tilde symbol under the escape button. Okay, so you can hit Y1 tilde M X1 plus B. When you do that, it's automatically going to populate all of that statistical information for you. And so you'll see your M and B is at the bottom, and it's the same as it was in the TI. And you'll see your R value is 0.97, just like in the TI. So you'll need to decide which one you like to use better. On the STAR test, you will have a TI 84 no matter what. And there's a good chance that you'll have the Desmos as well, but it's not guaranteed. Okay. Here's a second example. We're not going to work this example together. This is pretty easy. You're just going to need to go through those steps. And I would write those steps down. I actually have a cheat sheet that I have attached into the course toolbox. It's in your graphic organizers that has these steps step by step for TI. And so if you go there, you'll be able to work these out pretty easily. And if you need help, please come to the tutorials. Now, anytime they give you years, then you need to use numbers instead of the years. And so this says that it wants to know, it doesn't say. So basically, if you start here, this is going to be year 0. And then this is 1 year since 1991. And then 2 years since, 3 years since. And so you'll have to figure out what these red numbers are based on the number of years that have passed since you started. Now, in some questions, it doesn't matter if you use the years or not. But just to be safe, we're going to convert those to the number of years since we started. Okay, and then you can try this one on your own if you want to. Go ahead and work through the problem and then pause the video, and then you can come back and check your answers. So go ahead and pause. Okay, so now, if you check your answers, you should got your regression equation as y equal 4.56x plus 2.83. And then your R value is 0.98. So 0.99, that's a very strong correlation. Okay? And then to answer the last question, how many miles will he travel for 125 minutes? So if you're using Desmos or TI and you go to the table, then you can plug this equation in and then just go look at where the X value is 125, and it would tell you it's about 149 minutes. Okay. So what I want you to do next is we need to practice this. And the more you practice, the better you're going to get. If you are struggling understanding how to use the TI-84 or Desmos, please come to tutorials. Let me work this with you one-on-one. Miss Madison and I can sit down with you, or we can do it virtually on Zoom and just guide you through this. After you do it once or twice, it becomes pretty easy. And you guys have already done linear regression, so that part is not anything new. You just need to understand what the R values mean. Okay, so make sure you do your practice. Make sure you do your star checkout and your ticket out the door. And then I will see you next time. Take care.